Alright, so this is my 3D printer. Wanted to do a quick video about some of the changes I made to it recently, which is primarily this Z-axis. It's got a gear and it's running on a single motor. This printer design is originally based on a design called the Voxelox, and let's just show. So the original basically just used vertical. The stepper motor would have been, instead of this gear setup, we would have had the stepper motor mounted to this plate using spacers about this big, and you know, this would have been over where this thing is, and so you would have had one there and one there. And so this, let's look at the lead screws here. I'm using this build is based on OpenBuild's hardware, and you know, particularly the V-slot, so it's using these for the linear motion. And the Z-axis uses the OpenBuild's lead screws. The lead screws, they have 2mm pitch in between these, but they're 4 start, so you multiply that pitch by 4, and then every turn is actually 8mm of movement. And when you start to get to that level of lead on your screw, then it's possible to back drive it, and that was one of the problems I was having with my previous setup. Was that when the machine was turned off, the gravity of this carriage here was enough, the weight of it was enough for the screws to just settle on their own, and the left and the right side wouldn't really necessarily settle to the same degree, and so they would become out of sync. And so that's the whole reason for me trying out this this geared setup here. All the parts were designed in OpenSCAD. I modified a gear library that I found on Thingiverse by a user named Parkinbot. And the other thing, let's see. So previously I had also been using one of these. It's an inductive probe, Photech PS05M, and I basically had it mounted kind of like this on the side, and oh, what is going on with this? And one of the issues with these inductive probes, I have an aluminum bed here that's got build tack on the surface, but these inductive probes, the sensing distance is so poor with an aluminum plate. They're really designed for ferrous materials, that, you know, the amount of gap when it triggers is so small, it's like 1 or 2 millimeters, and then with the build tack on top of that, you have to subtract that distance out of it. And I was running into a lot of issues with when you have overhangs and you're printing and the print starts to curl up, and basically, you know, the probe would be interfering with the print in certain spots, and it would knock the probe around, and it would get the probe out of adjustment, and then when I go to start my next print, I would be grinding the nozzle into the bed and it would never trigger the probe, and it's all kinds of disaster. But so I've moved away from the inductive probe setup. Currently what I'm doing is a simple micro switch. This is triggered by the wheels on the carriage. I have my printer firmware set up so that when it homes, it does so off the edge of the bed, and the nozzle actually dips down below the bed surface, with, you know, just based on the height I set this at, which is fine because I've set an offset also in the firmware configuration that So it tells it that it's like -4 millimeters or something, and even that value isn't particularly. It doesn't matter that it's exact, because what I end up doing is, after I home it, well, for the initial setup, I do manual mesh bed leveling. So the motors are disabled right now, and I just want to show you what it looks like and sounds like when it's moving. There is some added noise from the friction of the gears, but it spins pretty smoothly. As far as backlash, let's see if I can focus this particularly. I mean, it's really very negligible. This one on the right side has just a hair of movement, and this side is actually, I can't get it. I mean, as soon as it moves, it's moving the other gear. Like, they're meshed perfectly on that side. And you know, I could probably adjust this slightly by loosening these again and moving things a little bit. And you know, this motor bracket is secured with 2 bolts, and those can be loosened, and you can rack the bracket slightly from the extra play in those bolt holes. And so yeah, the backlash is pretty good. You know, as far as backdriving, with this setup, and by the way, these gears are, the drive gear is 16 teeth and the output gear is 32 teeth, so it's a 2-to-1 ratio, or 1-to-2, and so that's given the motor just a fighting chance, since it's driving these 2 now instead of 2 motors. But I mean, these motors were already pretty over-spec'd, I think, for what they were doing. So but the other aspect of the gear ratio and how large these gears are is based on the shaft separation. So this shaft, I wanted it centered on this top 2060 extrusion, and then, you know, this shaft is in its place based on how this nut block mounts to the overall machine. So that was sort of the constraint of what determined the gear sizing, or the total distance between the gears. So I've got these pillow blocks. The gears are all press fit onto 8mm round shaft. I've got 3D printed pillow blocks. I'm using all 608 skate bearings, so they're real commonly available and cheap. Stop collar to the side with a washer in between there, and we'll come over to the other side and look at it. And so this pillow block is facing the other way. The pillow blocks have sort of a closed face that holds the bearing in, and it's actually curved on one side. It's just somewhat of a stylistic detail, but the open side is the flat of the 2, and you always want to have the washer in there, and then the stop collar to prevent it from popping out. These gear mounts have 608 bearings press fit into the top and the underside, and then there's these 8mm to 8mm coupler on the back, and I'll try to get. I don't think my camera likes that. So as far as back driving it, I can actually push this down, and it does go down. I have not been able to push it upward. I mean, I can lift the whole printer. Well, I don't have a good balance on it here, but with one hand. But it does not back drive it when lifting it.